Morning everybody, so we're going to get into today, which is our start of our algebra topic. So we've been going over all of our measurement topics so far. We're now moving away from that. We're getting into algebra. I will update the calendar after I have recorded this lesson. However, just showing you this page just to show you guys that it's all going to be here from now on. So if you're working from home, which most of you should be, always be looking here, and I will update it at the end of this recording. So algebraic expressions. We've dealt with algebra heaps throughout high school, and we're going to do through it again a little bit more. We're probably going to do the basics today. So if you feel like you already know how to do most of this, maybe skip to the end, see if you can do the examples, and then we'll go with that. But if you need any help, let's just start with here. And these are all just a little bit too skinny for me right now. So let's just change them all to the right width. Sorry, this is taking a bit. All right, here we go. So, algebra involves the representation or manipulation of unknown quantities. So algebra is always dealing with unknowns. And when we say unknowns, we really are representing these in a certain way. We use variables to represent unknown values. We can also call them pronumerals. Okay, they are really the same thing. Okay, so variables and pronumerals, they're the two words that mean the exact same thing, just letters that represent unknown numbers. Okay, so in algebra, letters are used to represent numbers. The most common one is probably x. We've all probably dealt with x being a number that we've used to represent something. The letters are called pronumerals or variables. Again, we will interchange these words so much in this unit, so just be aware that if I say variables or pronumerals, they're the exact same thing. They're just different words. You know, kind of like Mr. Hales and Super Cool. They mean the exact same thing. That was a joke, by the way. An expression is a combination. So an expression is a combination of numbers and variables. Connected by operations. So an expression is a combination of numbers and variables connected by operations. Now, when I say connected by, it means that between two terms, which we will explain in a little bit, there have to be operations connecting those two. So, for example, we could have something like 5x squared take 1, or we could have something like 3 outside of x plus 2 take away y over 2. These are all examples of expressions. They're all terms being connected by some sort of operation. Now, when I'm referring to a term, sorry, I don't need the comma there. A term is a combination of variables and numbers variables and numbers connected by multiplication and or division. They can have one of them, they could have both of them, but they are always going to be a term. Okay, for example, so 4x is a term because it's a number and a variable being multiplied together. Y over 3 is a term because it's a number and a variable being divided by each other. And then 7x squared over 2y would also be a term. Multiplication and division of variables all combined together. Just be aware of these because some people are very confused that maybe 4 and x are both individual terms. So this here is just one term, not two. And then we have a constant term. A constant term is just a number. So not all terms have to have variables in them. Some constant terms are just numbers. Oh, sorry, it's just a number, not a numbers. A constant term is just a number, so it will never change. It will always be the number. So let's say we have a constant term of 4. It will always be 4 no matter what we have. So let's write an algebraic expression. Let's say we have 7a take b squared plus a over 4 plus a over 4 take 1 plus 7x. So this entire thing is an expression. It's terms being connected by operations. -1 is the constant term. Because -1 is just the number. And then we have 1, 2, 3, 4, 5 terms, numbers and variables being connected by operations such as multiplication or division. 5 terms. And then another thing we should probably think about is the coefficients of some terms, okay? So when I say the coefficient of b squared, well, that is just this term here. So let's just point an arrow there. That's my b squared. What's going to be the coefficient of that term? Well, that's the number that the term is being multiplied by. And we see there's just a minus sign in front of that b. That means that the coefficient of b squared is actually -1 because we've multiplied that number by -1 to get us to that takeaway sign, okay? So just be aware of that. Coefficients is something a little bit tricky that confuses some people, and we should just keep that in the back of our heads. Order of operations. Order of operations still stands. Our numbers are represented by variables. These variables are not just some new things, they represent an actual number value. So what that means is that our order of operations still stands. We still add after we multiply. We still do the brackets before we do anything else, okay? BIMDAS still applies. Let's get into some examples. Write an expression for the following. So we're going to have to get used to some of the language that we use in algebra. Some of the language is going to confuse us because they could be written in different ways, but you have to know what each of these situations mean. So 3 more than twice of x. 3 more than twice of x. Well, that 3 more, that word more, indicates to me I'm going to be adding somewhere, because if I have 1 more than 2, that's 3. 2 plus 1. So it implies adding. twice, that word twice, implies multiplication. So I know my expression is going to have multiplication and I'm going to have addition. Twice of x is 2x. 3 more than that is adding 3. So that is my expression for my first sentence. Okay. B, the sum of A and B divided by 4. So A and B, the sum of them, we know that word sum means, that word sum there means I'm adding. So we're going to have A plus B over 4. Because the sum of them, A plus B is all divided by 4. It's not the sum of A and B divided by 4, it's the sum of A and B divided by 4. So be careful how you read them, because that would change the way that you write your expression. The square of the difference of x and y. This word difference means subtract, okay? So first of all, I'm taking away x from y, and then I need to find the square of that. Not the square root, the square. So x take y squared. And that would be my algebraic expressions for those situations. Now, we know that our variables represent numbers. So now, if we have a set of variables in an expression, and we know the values of those variables, we can substitute numbers in to make and evaluate our expression. So, evaluate if A equals 5, B equals -2, and C equals 3. So let's say I want to find B squared take away 4AC. What I always like doing is writing a bracket and a number inside it when I'm replacing a variable. So for example, B is -2, so -2 squared, take away 4 times, A is 5, so I write 5, C is 3, so I write 3. And I'll explain why I do that maybe after I finish this example. -2 squared is 4, take away 4 times 5 times 3, 4 times 5 is 20, 20 times 3 is 60, so 4 take away 60, which is going to equal, or get me to, -56. Now, why have I written the brackets in there? Well, if I was to write this instead as -2 squared, well, that may confuse someone as to writing -4, and that would change your answer from -56 to -64. So maybe just be a little bit careful when you're substituting things in, that you know exactly what you're substituting. I'm squaring -2, not 2 and then a negative in front of it. Okay, so that's all we're really going to talk about in terms of algebraic expressions, just getting into the start of this topic, getting our head around some of the things we may have forgotten. I'll put the questions at the top of this video for you guys to have a go at on your own.